Today we're going to be learning about conversions in the metric system. To make these conversions easier, it's important to memorize the acronym King Henry died by drinking chocolate milk. This relates to units of kilo, hecto, deca, your base unit, which can be grams, meters, or liters, deci, centi, and milli. Sometimes we use micro. So looking at these units, we can see by our exponents here that we either are increasing or decreasing by a factor of 10 from our starting right here from our base. So 10 to the first, we would move our decimal point from 1 to the right, which would then give us 10. If we move it one more, that would be 10 to the second, which would give us 100. And if we move it again, it would be 10 to the third, which is 1,000. So basically, this shows either moving your decimal point to the right or to the left, and how that could correspond with factors of 10. So here, on the opposite side, if we take 1, and we move this decimal point, if it's a whole number, we can always assume that our decimal point is on the right side. If we move it right over here, then our decimal point would be right here, and then we would have 0.1. If we move it again, we would have 0.01. And if we move that a third time, then we would have 0.001. In pharmacy, we always want to put a 0 before the decimal point if there's nothing in front of it. But we don't use trailing zeros. So let's just say we have the same number. We would never write 0.0010. We don't write that trailing 0. I write micro, this unit right here, off to the side, because as you can see, it's 10 to the negative 6. We left off with milli at 10 to the negative 3. So we have a 3-looped jump from here to here. So that's why I put it off to the side, just to make sure that no one gets any mix-ups while converting. So going back to our base units, we have gram, meter, and liter. Gram is a weight-based unit. In pharmacy, we would only use that to measure solids. Meter is not used too often. That measures distance. Liter is a volume-based unit, so we would only use it to measure liquids. In other specialties, like if you're, for example, making a cake, you might interchange these units. So when you measure flour, which is considered a solid, you might use a volume unit, like cups. Usually people measure flour in cups. In pharmacy, we wouldn't do that. If we're working with a solid, like a powder, we would always weigh it out using and some type of form of grams. One thing to note here, if you're looking at the units, we have kilo, K, hecto is H, deca is DA, our base would be either G, M, or L, deci would be D, centi would be C, milli would be M, and micro would be MC. And then you would attach that to your base. So, for example, if you see kg, that would be kilogram. If you see G by itself, that would just be gram. And if you see mcg, that would be microgram. The pattern I want you guys to notice here is that the last letter will always be what your base is. So last letter is always your base unit. So remember, that's G, M, or L. And if it's alone, then that's just simply your base. Okay, we're going to get started on these examples just so I can show you guys exactly what I mean and how this plays in practice. So the first example is 3 liters is how many milliliters? Since we're working with our base of liters, we know that we're measuring out a liquid. To do these problems, we're going to start off with our acronym. Keene Henry died by, I always put my base in square because it helps me, drinking chocolate milk. Okay, so liters is our base, so we know we're starting right here in the middle. And then we want to move to milliliters, which is our last M. So 1, 2, 3. We moved 3 decimal places to the right. So we're going to do that with our actual 3 for 3 liters. So here we have our 3. Since this is a whole number, we know that our decimal point is right on the right of it, right here. So just as before with our acronym, we're going to move it the same direction, the same amount of spaces. So we're going to make 3 loops, 1, 2, 3, to the right. When you make your loops, you can always assume that where your loops start is where the decimal point was in the problem, and where your loops end is where your new decimal point is. So that's our new decimal point right here at the end of the loops. And what you want to do is you want to fill in each loop with a 0. And that will be your answer. So our answer here is 3,000 milliliters. Okay, so now we have an example where we're going to move the decimal point to the left this time. So we're working with centimeters, going to kilometers. Our base here would be meter. So we know that this is a distance problem. We're working with distance. So once again, same thing. We're going to start off with our acronym. And we're starting with centi, and we're going to kilometers. So 1, 2, 3, 4, 5. We moved 5 units to the left. So I'm going to make my little arrow to the left. And then we're going to write 20. Once again, 20 is a whole number, so we know that our decimal point is right following that 0. 1, 2, 3, 4, 5. In pharmacy, as I said, we want to make sure that if there's nothing before our decimal point, that we are always adding a 0 in there. So we're going to add a 0 before our decimal point, and then we're going to add a 0 into all of our loops. As I said before, once again, in pharmacy, we leave off trailing zeros. So our answer here would be 0.0002. We don't add that extra 0. So for this example, we have 625 milligrams going to micrograms. Our base unit here is grams, so we know we're working with a solid. Let's start with our acronym. And then for this one, we're going to put our little m off to the side, just because we're making that 3-looped jump over here, because micro is off to the side. So we're going to be moving from milligrams to micrograms. So remember, this one's milli, this one's micro. So that means we're moving to the right. So 3 to the right. 1, 2, 3 to the right. So 625 is a full number. So we know that our decimal point is going to be at the end right here. So 1, 2, 3, new decimal point right here, fill in zeros. So our answer would be 625000. Okay, so after we're done with all these examples, it's important to kind of go back and make sure that all the math makes sense. And what I mean by that is we should be able to see that the smaller units fit into the larger ones. So looking back at our kilo to milli, milli is the smallest unit in the acronym. Micro is smaller than milli, but milli is the smallest in the acronym. So over here, I'm going to write smallest, and then over here, I'm going to write largest. So our small units should be able to fit into our larger units. So looking at our first example, milli is smaller than liter. And we can see that's true because we have 3,000 milliliters per 3 milliliters. So that would check off. The next example shows centimeter going to kilometer. Centimeters are smaller than kilometers, looking at that chart above. And this makes sense because we have 20 centimeters for every 0.0002 kilometers. 20 is larger, so that holds true. Our next example, we're going from 625 milligrams to 625,000 micrograms. Micrograms are smaller than milligrams, and this holds true because that's obviously a much larger number. So all of these check off, and I think it's important just to kind of make sure because we're working with factors of 10, so any little slip up that you can do when converting could be a 10-fold, 100-fold, even 1,000-fold increase in dosage up or down for your patients. And this could obviously be deadly, so we want to make sure that we're accurate when dosing because at minimum, you're giving a 10-fold increase or decrease in dosage. So it's just important to be aware of that when doing these equations.